Okay, so in the first lesson, okay, we talked about strong acids and weak acids. And now we are in lesson 6, and we're going to be talking about strong and weak bases. So, again, a strong base is just an ionic compound that can dissociate in water and release OH minus. Okay, so we call these metal hydroxides. A weak base is an anion, which means it has a negative charge. Okay, so if we look at this example right here, it says calculate the pOH, all right, which is the opposite of pH, of a solution that dissolves 0.21 grams of sodium hydroxide. Sodium is a metal hydroxide, strong base, into water to make 12.5 liters of solution. So again, like I said, sodium hydroxide is a metal hydroxide that when we dissociate it or when we put it in water, it dissociates into its ions. Okay. Now, a strong base is a metal hydroxide that will dissociate to produce OH minus. Okay. If we just think this question, guys, is asking us for pOH. Okay. pOH is negative log concentration of hydroxide. So in order for me to solve what the pOH is, I need this concentration. But the information given in the question is not about OH, it's about sodium hydroxide. So again, we have a single arrow, we can ride the molar coaster. So it told us the mass of sodium hydroxide was 0.21 grams. We know the molar mass of sodium hydroxide is 22.99 plus 1.01 plus 16 is 40. Okay. So the moles are 0.21 divided by 40 is 0.00525 moles. Okay. Now, to figure out what the concentration is, I need to do C equals N over V. It gave me the volume in this problem, so that should not be an issue. I'm going to take my moles, divide by my volume. Concentration is 4.2 times 10 to the negative 4 moles per liter. Okay, that's the concentration of sodium hydroxide. However, we don't want that concentration. We don't care about the concentration of sodium hydroxide. We care about the concentration of hydroxide. But we think, if I started with this, I put it in water, I no longer have sodium hydroxide. I only have these products. Because it dissociates 100%, the initial concentration, divide by 1, multiply by 1, they are the same. Okay. This process is exactly the same as the process that we did in the previous example for the strong acid, except it was an ionization reaction. This is dissociation. Once I have the constant, again, I have to show you have to show me this because you have to understand the difference between the concentration of sodium hydroxide and the concentration of OH minus. Guys, once I have that concentration of OH minus, this problem is extremely easy. I just sub it into my pOH formula, like so, negative log 4.2 times 10 to the negative 4 moles per liter. So my pOH is 3.37, 67, ... Okay, there were 2 sig digs, so 2 decimal places, 3.38. And if I want to figure out what my pH is, I just do 14. This isn't in the question, but I can just do 14 minus that. And my pH is going to give me 10.62. Okay. You might think that's a bit low for a strong base. You're not wrong, but you have to think we're putting in a very small amount. 0.21 grams is extremely small, and we're putting that in 12.5 liters. 12.5 liters is a lot. Like one water bottle has 500 milliliters. Okay. So that's just kind of the thing that you have to put into perspective. Okay. That would be like 25 water bottles. All right. Worth of water. So again, this is how we figure out the pOH and pH of a strong base.